Starting. Hello, everyone. Hope you're doing super well today. Today is our third Unity session, and this session is going to be divided into two parts. The first part, I'll explain just some more basics inside of Unity, such as UI creation, scene management, player health. But before I do, I'm also going to discuss how to create a build for your game, because you're going to need this for your later submissions, and how we use source control, which is GitHub Desktop that we talked about before, in order for you to work together as a team. This is going to be relatively basic, just so that you can see what's happening. And then we can just keep moving forward with this, all right? So I'm going to start by sharing my entire screen this time, because last time, apparently, some of the screens didn't show even though they should have. So that's okay. And I'm going to share. I think you all can see it, مفروض. This is me talking to Kutub, and it's gonna go to the side and GitHub Desktop. Okay, so if you have seen our project, you will know that we have our project is all on GitHub, and Fouad has done all of it, and you can see all the different branches inside the current branch thing. So the way you get to the project in the first place is by going into GitHub Desktop, which looks like this, and then you click on Add, and then you choose either clone repository or add existing repository. When you clone it, you just copy the link from GitHub and you paste it over here. And if you want to add an existing one, you can add it from inside your computer. Okay? So once you do this, it will be around and on your computer. The thing about branches is by using branches, you're all able to work on the same project at the same time. Okay, so currently, for example, I'm using development 3 because this is our third session, and this is the branch that I'm going to be using to explain things to you. Let's say that you worked on the branch and you wanted to push your work to someone else and the entire team, basically. This is when you click on all these checks, and then you write a description, and then you commit. And then after you commit, it turns into something called a push. And then when you push your work, it's uploaded to the cloud and everyone can download it and check it out. So what I'm going to do right now is I've got the development 3 branch, and I want to see if there are any changes to it before I start working. So I'm going to choose my development 3 branch, and then I'm going to pull. So we're just pulling right now to see if anything has changed. And I think we're good to go. So yeah, I'm just fetching. So the difference between fetching and pulling is when you fetch, you just check if there are any changes. When you pull, it means that changes were found and you were updating them. So technically what happened is I already updated the changes when I clicked on pull, but I fetched again just to make sure that everything is fine. All right. So when we look at development 3, we can see that we had some changes 3 hours ago. All right, if we look at development 2, that was last month. If you look at the main branch, which is the main thing that we work with, this was 11 days ago. And generally, when you're done with a branch, there's something called a merge that you can do, and we will explain this later on. But generally, you just click on choose a branch to merge into development 3. Generally, you have a main branch that you work on and a development branch that you develop on. So you merge all your work into development, and then when you're absolutely sure of it, you can merge back into main. And after you do this, you need to share your game out with people. So how exactly do you share your game out with people? And this is by doing a build. But before I go on and talk about builds, is this very brief summary of GitHub Desktop, does it make sense? Do we have any questions about it? Because I did go relatively fast. Okay, in summary, over here, the current repository is your project. The branch is the thing you're working on. And to fetch means to grab things and put them on your computer so that you can see them yourself. Okay. And then when you're done working on a branch, you plop it back in by merging it. That's basically it. All right. So you have your game. Okay, so right now what happened is after I pulled, the scene changed because someone that was working on this branch, Fouad, he changed something in the scene, and now Unity is telling me that the scene was modified externally. And the reason it was modified externally is because GitHub Desktop was the one that changed this Unity file. And once it changed it, we have to reload it so that we can get the new information. So I'm going to reload over here. And I'm going to try to save on bandwidth a bit. All right. So now that the scene is reloaded, we have the scene just, it's basically a new scene. Sorry, it's a refreshed scene. And now we can see the hearts over here, and I'll explain what it was about. So anyway, builds. Usually when you want to build, you can go into File, Build Settings, and then you have to add all the scenes that you want to build, that you want to have inside your game, inside your build. Okay? So you go, for example, we put all our scenes inside the scenes folder. So we are in the sample scene, and today we're going to build the main menu scene. All right? So what we do is we click on File, Build Settings, and then we drag the scenes we want into our build. Okay? And generally, the scene that's scene 0 is the one your game is going to start with. So this is why we put main menu above sample scene. Once we're done with this, we click on build, and then we choose a location. So I'm going to choose a new folder, and I'm going to name it builds, and I'm going to save the build as dev3. Okay. And then once I click save, the build is going to start building, because that's what builders do, just like Bob. Bob was a pretty good builder, I think. And usually what it does is it takes a bit of time to, get all the scripts together. It packages your photos, your animations, everything, and it puts them in one file. The file is usually relatively compact, but it just, it's a compact file, and you can use it, you can share it around with different people so that everyone can play your game. So generally, there are also many different ways to build. So you can see over here that I can build for Windows, Mac, and Linux. And by clicking on target platform, I can change if I want to build on Windows, Mac, or Linux. Now, if you go into your, what's it called, into your Unity hub, and you go into your installs, these are some of the games I worked on before, you can see that I have different versions of Unity. And in each of them, you can see that we have an Android, WebGL, iOS, Windows, Mac, blah, blah, blah. So in each of these, you can see a different kind of thing that you can build for. Okay, so for example, in 2021.3.14, I downloaded all the packages that allow me to build for Windows, iOS, Mac OS, WebGL, and Android. Whereas the one that I'm using at the moment, which is 22.3.5, is only for Mac OS. Okay. If you ever want to add more of the modules, you can just click on the settings button, add modules, and then download whatever it is you want. Okay. So if I want to download Android support, I can just do it from here. Okay. For some reason, the build has failed, and this is because the player script had some compiler errors. Okay, so sometimes you also have problems with the library. So when there's a problem with the library, you usually close the game, and then you delete the library package, and then you just open it again. I'll just show you where the library package is, and I'm just going to skip a step of opening the app and just show you the scene directly. So generally, you open your project. So this is the GA Platformer project. You go into assets. Actually, you don't need to go into assets. As long as you're in the Platformer folder, you can see all the things over here. So for example, in this library, this is the thing that I would usually delete. And I would also delete temp and logs. And then I would restart the build, and then it would work. But I'm not going to do it now because this would take a while, because as you can see, the library is 1.5 gigabytes large. So today's lesson is, this is just the general idea of how to build. Okay. Does anyone have any questions about the building part of things? Or are we good? It's just you click on the build button. Perfect. Okay. Oh, I forget you can't see me thumbing up, but that's okay. Type. So this is the scene that we worked on last time. And if I click on play over here, okay, means let's see. Okay, so apparently I do need to do this. So what I'm gonna do is I'm gonna pause the recording for a second, delete the library, and then restart this. Restart the recording once the library has been rebuilt. Okay. All right. So while we were waiting for the game to just refresh, I deleted the library. And then I was like, we have a bit of time. So we decided to make a game build. So once you're done building your game, you have a game build and you have this thing which is do not ship. So just, don't send it out. So whenever you want to send your game build to someone, you grab all the folders or the files that created a game build, and then you send this out to people. All right. So yeah, this is basically how you build a build. Build a build. Sounds like build a bear, but like there are no bears involved. So after you're done building your game, you should be able to get back on track and see what we have for you today. So I just double clicked on my sample scene. Whenever you see untitled main camera, you can more or less ignore it and just open the scene that you want to work on. Again, turning off the camera for bandwidth. Okay. So over here, what we're going to be seeing is Unity loading yet again. Unity is very good at doing some loading, like exclusively loading, but that's okay. We will survive. Okay. So we have our game. We have our little character. As you can see, he is moving around left and right, and he can jump. He can't really quite get to this very well, so it depends on how you're jumping him to actually get to the top. And he can shoot by clicking on the buttons, on the shooty button. And depending on which way he's facing, he's going to be shooting. And we also have these spikes. So when you step on the spikes, you actually get hurt. And as you can see, your hearts go down. Okay. And then when you get to a point where your hearts go, you will restart the level and you will restart from the top, from over here. Okay. So this is what we're going to talk about. We're going to discuss how the spikes are created. We're going to discuss how to create the hearts. And we are going to then discuss the main menu that you are going to be starting your game from. So just to give you guys a quick overview on what each of these parts are. I'm going to start by talking about the spikes themselves. So as you can see over here, we've got these spikes, right? So each of these spikes is a game object. And if you remember from last time, the blue things are called prefabs. And we created prefabs of these spikes. So I'm going to open the spike by double clicking on it. And this is called a PF spike because it's the prefab of a spike. And as you can see, this has an image, a sprite renderer, and you can see it over here. I'm actually going to try to double click and open it. Okay, 1, 2, 3. There it is. It's a tiny, tiny, tiny little sprite, and it has a certain size. It is an 18 by 18 tile, which is wonderful. And what we did to it is we grabbed it and we put, obviously it's going to have a transform, which is its position in the world. It has a sprite renderer, which is the thing that's showing us the spike. And it's got a box collider. So if you remember, I talked about rigid bodies and their importance in getting things to move, but the spikes are going to be stuck on the floor and they're never going to move. So there's practically no point in putting a box collider to them. Okay. Also, just as a reminder, all our assets are free assets made by someone called Kenny, and you can go to kenny.nl to get all of them. He's a very sweet person. He's been doing this for free for a while, so go support him if you can. All right. So back to the spikes. So on the spikes, we also have a script called spike. All right, and the spike script is the thing that sees if you are the player, and if you are the player, you'll take damage, and we will get into it in a second. But I wanted to show you a few ways of putting the spikes into your scenes. So if you remember from last time, we have these things called our tile maps. Okay, so our tile maps allow us to create tiles onto our screen, and they allow us to put things wherever we want them to be. Okay, so over here, one of the things that we did was we did not use the tile map and instead set the prefabs as is. So what we did is we grabbed each object and we put it inside inside the prefabs tile map. And each of these is a spike in and of itself, okay? And as you can see that each one of these spikes takes up a space equal to that of a tile, but technically speaking, the collider is only at the bottom. So this yellow line that you see, or green line that you see over here, this is where when you hit, you're going to take damage. You are not going to take damage if you do not touch this part of the tile. Okay. Do we have any questions? No? Okay, cool. طيب. So let's look at what the spike code does. So I'm just going to double click it. Hopefully it'll open. Okay, perfect. So the spike code is pretty simple. We have this thing called a trigger, and we are basically checking if our collider, which is a 2D collider, is colliding with something that has player on it, then get the player component and take damage. Now, I don't think we wrote the take damage script last time, so we will look into it. But let's just explain this relatively quickly. So on trigger stay is a function that Unity writes, okay? As you can see, when I hover over it, it says Unity, two dots. On trigger stay 2D is called once per frame for every collider 2D that is touching the other trigger, okay? And this only works in 2D physics. So if I want to write something else, like let's say you've got stay, what else do you think we've got? I'll give you a hint. One of them is on trigger enter 2D. Can you tell me what is the equivalent of this for leaving? So I'll show you. I don't want to write it out because if I do, then it will probably show. Can anyone guess what the opposite of on trigger enter is? Yes, exactly. Well done, Ahmad. It's on trigger exit. So I'm going to write on trigger enter. Where is it? Why isn't it working? It's being poopy again. Okay, there it is. On trigger. So you can see over here that when I write on trigger, it's automatically going to show me on trigger enter 2D, on trigger exit, and on trigger exit 2D, and on trigger stay. But you realize that it did not give me on trigger stay 2D. And the reason it didn't is because this already exists inside our screen. So the difference between on trigger enter 2D and on trigger exit and on trigger stay is that on trigger enter only checks the first time you enter. On trigger stay checks as long as you're there, and on trigger exit checks only when you leave. Okay, and then we have this thing called. Does this make sense? First of all, are we good with the triggers? Great. Okay, so next we've got the tags. So if you remember, we have our player over here, and our player has this thing at the inspector at the top called a tag. And we created a tag called player, and we gave it to the player. So what we're doing here is once something is being triggered, it's being triggered with a collision. So we're checking if the thing that we are colliding with has player as its tag. If it does, we are giving it damage. So if we click on the player over here and scroll down a bit, you're going to see that we have a player controller. And considering that we are getting the player component from the collision, we're actually not getting it from the collision. We're getting it from the game object that this collision exists on. We know that there's a function called take damage inside the player controller, and I'm going to show it to you right now. What I did at the moment is I command clicked or control click on Windows, and this will automatically take you into the script. Another way of doing it is just double clicking on the player controller. And once you do this, it will automatically open the take damage script for you. Okay. So what we're doing in the take damage script is we're checking. If we cannot take damage, then return. And what return means is just leave the function that you're calling at the moment, okay? And then if we can take damage, then it's going to ignore this. By the way, the exclamation point means not, okay? And you can see from the top over here that we created a Boolean, where a Boolean is basically a true or false value. And this is where we're setting the can take damage, all right? So if we cannot take damage, then just leave and don't do anything else. However, if we can take damage, first set can take damage to false, and then decrease the health that we have, and then set our game object's color to red. And then Fouad's going to explain the player event channels in a bit. But basically, the event channels are things that allow you to call functions, and they allow you to make things happen. And then if the health is less than 0, then what you're going to do is you're going to die, and you're just going to restart the player wherever we respawn. And then we are going to give them max health by healing them. And the way we know what max health is because we've set max health for a certain amount, and we are causing an event to happen whenever we want to heal. Okay? Hala, the events are something that Fouad will explain, as I said, and we will get to them soon enough. All right? Okay, one of the other things that we wrote inside our player controller, first of all, we have our max health, which is the maximum health that you can have. We have the health, which is our current health. So depending on how much we've taken damage, we're going to have a different kind of health. Our sprite renderer is the thing that is showing our character over here. So if I look into the player and I go to the, where is it? Okay, so our player sprite is inside our player. You can see that we've got our sprite renderer over here, and it is showing us character 006. I'm going to zoom in on it with this thing over here. So you can see this is our character, and this is us zooming in on him, okay? So our player sprite is referenced from our player. So if you look at the player controller over here, you can see that our player sprite has been set over here, and our max health is actually 4. So how does our max health say 4 over here if it says 5 inside the code? Well, basically, Unity is going to look at whether Unity is going to give priority to whatever you put in the editor. And considering that it's a public value, this means that the value is available for anyone to see, and this means that anyone can change it. And the person or the thing that's changing this value is Unity. So Unity is setting max health to 4. This is why when we play the game, you're going to see that we're going to have 4 hearts instead of 5. And the max health is not going to be 5, it's going to be 4. Okay? So just to summarize what I just said, Unity gives priority to whatever is written inside its inspector above that which is written in code. Okay? That's just it. So what we're doing over here is we are setting a damage timer because just like we said before, we need to make sure that when we do take damage, it will be after a certain point. So I'm going to show you what I mean by this. But basically, the idea is that we are checking if we can take damage, and if we can take damage, then if we cannot take damage, we're going to set a damage timer, and the damage timer is going to increase as time goes on. And then once it gets to the certain point, which is damage time, then we can take damage again. And once we can take damage again, our color changes to white instead of red. Okay, so I'm gonna click on play, and actually I'm gonna first show you over here. By the way, what I'm doing on Mac is I'm basically using 2 fingers and dragging outwards. So this is how I'm making the screen big. But another way to do this is by right-clicking on game and maximizing the tab. Okay, so I'm just gonna walk onto the what's it called? Onto the spikes, and I don't know if you can see it, but basically when I walk onto it, I turn white and then red and then white and then red every time I take damage. Okay, so I just jumped so I can show you how I'm turning white, and then as soon as I hit it, I turn red again. Okay. Also, if you always want to make your game go into maximum size whenever you're playing the game, one thing you can do over here is here. I'm just gonna grab the game and put it to the side. Where is it? Yeah. So over here, instead of play focused, you can choose play maximized. So once you do this, it means that when you click on play, it's going to maximize your screen. But I generally prefer to play focused so I can see what's happening in the scene as well. Okay. Now, so did everyone get the spikes code? It's relatively simple. But it's fine if there's something that's missing, it's fine if you ask about it. It's no biggie. Cool, awesome. طيب. Now that we've written our spike scripts, you can see that the things that we practically need to make the spike script work is we need to collide with something, and the thing that we need to collide with is the player. So this means that the spike code does not exclusively need to be on this spike. It can be on practically anything we want. So what I'm actually going to do is I'm going to duplicate the ground. So I'm going to click on right click, duplicate, or you can click on Control D or Command D to do this. And then I'm going to turn off the first ground. So the way I'm doing this is by clicking on ground and then clicking on the check. And then on ground 1, I'm going to add a component, and this thing I'm going to add is a spike. So by doing this, what just happened is I added the spike component to ground 1. And by doing this, I technically turned ground 1 into a spike. Now let's see if this is going to work. No, most likely what's going to happen is it's not going to work, and there's going to be a reason for this. So this is us. We are moving around, as you can see, and we are moving left and right, but we are actually standing on the ground, right? And if I hit this, the spike, it's going to attack. So let's go back into our code and check why this is happening. So here, can you see this word over here? Can anyone type what it says? صح, exactly. It says trigger. So what a trigger does is it triggers an action. And over here, we do not have it as a trigger. So we do need to set it as one. All right. So the thing is with colliders is there are two types of colliders. There are colliders that you can pass through, and there are colliders that you cannot pass through. So the trigger is a collider that you can pass through. And I'm going to click on play and show you what's going to happen at the moment. And I'll explain the importance of the trigger in a second. Just as soon as the thing starts. So I'm going to maximize. And as you can see, we fell through the floor and our health is decreasing. Okay. So why is this happening? Well, basically in Unity, a trigger is something that, okay, let's say that you were making a game, and inside the game, when the player gets too close to an enemy, the enemy turns around and starts running after them. How does the game know that the player is actually getting too close? Well, basically, people have a circle collider on an enemy, and then once you get into this collider, it makes the enemy turn around and attack you. But again, to know that you are in the player, to know that the player is inside the enemy's vicinity, you basically can use triggers. This is, again, one of the ways that this works. And yeah, so to summarize, a collider is something that you collide with. Whether you can walk through it or not is denominated by the trigger function. So if something is a trigger, this means that you can walk through it or fall through it. Okay. If something is not a trigger, this means that you're gonna smash into it and not be able to go through it. So does this answer your question? Okay, awesome. So yeah, this is basically like a quick summary of what it is. I can show it to you, but we have quite a bit of things to show, so I'll be moving on to discuss UI and canvases. So this thing over here, what is this? This is the canvas. And as you can see, as soon as I double clicked on it, it exploded in size. And now you can see that the map is very tiny at the bottom of the scene. Here, I'm going to just zoom into this. So you can see that the map is very tiny, and you can see that the screen is huge. So why is this? Well, basically, whenever you want to create a canvas to show something, you can see that when I click on play, you can see that so the platform we made, so the platform was made a trigger? Yes, exactly. And this is why we fell through the platform. And because in our code, we said on trigger, do something, we had to do it so that we can trigger the collision. Okay? So let me just check that everything is clear. Okay, perfect. So as you can see over here, inside this game, when I'm moving around, you can see that the spikes are disappearing from view and reappearing into view. You can also see this with the platform, but the hearts are always staying in place. So what exactly are we using? What is the sorcery that we have over here? Well, this is basically the canvas. So whenever you're playing a game, you can see that the UI always stays in place, and UI stands for user interface. So a user interface is something that the user is going to be seeing at all times. And an interface is something that is going to be showing in front of you, basically. And the way we do interfaces in Unity is through something called a canvas. So a canvas allows us to have text, allows us to have buttons, allows us to have panels, allows us to have even animations at some point. I hate using animations in canvases, but they work. Okay, you can also have, for example, whenever you're starting a game and you need people to put your usernames and passwords, you do it with canvases. So I'm going to create a canvas just to show you what it's like, and then I will discuss all the parts of a canvas over here. So to create a canvas, you click on right-click, UI, and then you go into canvas. So over here, you're going to have a canvas that's created. And you can see that it's got a rect transform, it's got a canvas, it's got a canvas scaler, and the graphics raycaster. Okay. Inside this canvas, I'm going to create a let's say a text. So what I did over here is I right click and I clicked on text, and this text, I'm going to call it hello world. Okay. And inside hello world, I'm going to go into the input text and I'm going to write hello world, world. Okay. So this is the current size of hello world. Now, what happens if I click on play and then walk around? So I'm going to click on play and I'm going to walk around. You can see that hello world is going to stay in place. Now, what happens if I maximize this? Well, hello world just got really, really small relative to what it was before. Okay. So this is weird. Why is this happening? Well, basically the idea is that this depends on the canvas and what kind of canvas you're creating. So in this case, our canvas is going for a constant pixel size in its scalar, when in truth, we want to create it as a constant screen size. Okay, so it's going to scale with screen size. And what this means is we are going to set a certain size that we want it to follow, and the size that we want it to go with is 1920 by 1080, because this is what full HD looks like. So once we do this, this means that anyone that's playing on a 1920 by 1080 screen is going to be seeing the game this way. And this is a pretty small hello world for what we expect it to get. But this gives us an accurate size of what it would look like if it was on a phone. Okay. So what I'm going to do is I'm going to increase the font size by dragging on the font to the right, sorry. I'm going to keep going until I get it to something big. So this is pretty big. I think I like it. And then I'm going to go into the rect transform, and I'm going to choose to connect it to the top right part of the screen. Okay. So once I do this, you can see that this thing over here has showed up. And the point of this is to say this is where your text is anchored. So the point of anchoring is we all have different phone sizes, right? So if you remember the iPhone 4, the iPhone 5, it's a bit different from the iPhone 11 and the iPhone 12. Same thing with the Samsung phones, with the tablets, etc., etc. Each of these has a different screen size. So by anchoring our UI elements to different parts of the screen, they won't overlap, or if they do overlap, we'll make sure that it makes sense that they overlap. Okay, so an example of this is, let's say that you have a screen with a logo, and you want the logo to be at the top of the screen. All right, if you use a small screen and you anchor your logo at the center, chances are that on a longer phone, the logo is going to look closer to the center. So this is why you decide to anchor your logo to the top of the screen instead of the bottom. Okay, sorry, instead of the middle. So after I do this, after I set the anchor to the top right, also tell me if this was clear or not. I'm going to set the position of the X and the position of the Y to 0. So once I did this, this now appeared at the top right part of the screen. As you can see, it is literally at the top right. Okay. What I'm going to do at the moment as well is I'm going to increase its size, and I don't know how much I want to do it. So this is why I'm going to grab this blue dot over here, and you can get it out by clicking on the letter T on your keyboard. Okay. I'm going to drag it out, and now hello world exists. Okay. I'm also going to drag it down a bit. So over here, and I'm going to plug it this way. So usually it's able to snap. So once I snapped it, you can see that now hello world exists. And even if I make the screen big, or if I make it small, hello world is going to take up the same relative space on my screen. Does this make sense? Perfect. Okay. طيب. So now I'm going to remove hello world, because we have something even cooler than this that I wanted to show you, which is the main menu. So your main menu is the thing that you're going to be working with. It's the base of everything that you have. Also, do you see the small star over here? This means that I've changed something, and I really do not want to change anything at the moment, because I want the game that you have to be exactly the way I have my game. So I'm going to double click on menu and click on don't save, because I don't want to save. Okay. So right now you can see that I don't have the star anymore over here, because this is the new main menu. And you can see that we've got the start button and the exit button. All right, so we're going to discuss this relatively quickly. We're not going to really need the grid, so you can ignore this at the moment. So you remember we created the canvas by clicking on right click, UI, canvas. And then inside our main menu canvas, we've got a few things. We have our text, we have our start button, and we have our exit button. All right, and then we place them all under each other. There are a ton of things that you can do with the UI over here. You can put them in horizontal layouts. You can put them in grids. You can connect them to each other. You can have drop-down menus. You can have, I'll just show you what you can have, basically. Scroll bars, scroll views, input fields, drop-down menus. You can have different kinds of things such as images, texts, and panels. A panel is a pretty cool thing because it's basically dividing your screen into different sections. I like them. I usually use them a lot at work. But one thing I wanted to mention as well is never ever use sprites inside your canvas because they will not show. Always use images, please. I've made this mistake and lost days of work to accidentally putting a sprite instead of an image inside of a canvas. All right. So this is just something to keep in mind. So buttons. Generally, whenever you have your main menu, you're going to have a script that's going to control your main menu. So this script is predictably called main menu. And what the main menu is going to do is it's going to have two buttons. The first one is to start the game, and the second one is exit the game. All right. So in the start, actually, yes. Okay, so Yara asked a question, and no, is there a difference between a sprite and an image on the canvas? Yes, there is a difference. I will show you right now. So I'm gonna go into the main menu canvas, UI, and then click on image. So as you can see, we just created a square. I'm gonna anchor it to the bottom of the screen. So what I did over here is I clicked on Shift and Option. I think it's Shift and Control on Mac or Shift and Alt on PC, sorry. And this allows you to not only anchor the item to the bottom, it also automatically sets it to the 0, 0 position. Okay. And then the image, I'm gonna give it the image of this dude over here. So you can see our little guy, he's just a little boy. And then I'm gonna set it to the native size. The native size is 100 by 100, so this is perfect. And then if I decide to add a sprite to the object sprite, and I'm gonna add a square, you cannot see the square, okay? Where is it? You can't see it, okay? It's over here. It's this little tiny box in the middle between the start and exit buttons, okay? And no matter how much I zoom out, it's gonna be, not really there. I just gave it a size of 100 and 100. It didn't show up. I'm gonna give this another 100 by 100 by 100. So, sorry, 100 by 100. Command, it didn't show up very well. So I'm gonna give it a few more zeros. And now you can see that it's a giant square, but this square is not showing up on my screen. And the reason it's not showing up on my screen is because sprites are seen by the main camera. And the main camera is currently looking at this space over here. So even though we created a sprite, a square, and it was really, really big, it's literally not even in the view of our camera. So this is why whenever you want to have images, images inside your canvases, make sure that they are images and not sprites. Okay? Does this make sense? In which case do you use a sprite and when do you use an image? You use a sprite inside your game. So this means that your character is a sprite, your enemy is a sprite, your tile map is a sprite, and you only use images inside the canvas. So, and the way you know which one to use is basically, okay, just undoing. Okay, so the way you can know which one to use is when you click on right click. If you're creating a 2D object, you're going to use a sprite. Okay, if you're going to create a UI, you're going to use an image. So this is relatively like it's all available, it's all there, but generally just use images for UI and sprites for everything else. The thing is, you can use the same image, the same picture, let's say, for everything. It's just sprites are exclusive for the game, for like the actual things that you see moving on screen, and the text and the UI uses images. Okay. No, it's fine. This is important, so it's okay if you're taking a bit of time for this. So the canvas is just visual. You can say that. Basically, if you're creating main menus, if you're creating pause menus, if you're creating any sort of menu, any sort of health that you're going to see on screen, any sort of, let's say, buttons that are going to be permanently available to the player no matter which way they turn, then you will most likely be putting this inside a canvas. So yes, a canvas is, you can say that it's just visual, but it's also functional depending on what you want to do with it. So let's say you wanted to create a login screen. Okay, a login screen is going to use a canvas because it's a user interface. Okay, so this is when you're going to be using an image. And just like I said, okay, so I'm gonna do this thing where I'm gonna create a 2D object and I'm gonna create a sprite, and it's gonna be a square. And I'm gonna give this square the, where is it? I'm gonna give it our cute little guy. Oh, please hide the things I don't want to see. So I'm gonna give our cute little guy his existence, and I'm gonna set his transform to 0, 0. Sorry, 0, 0. So where is our little guy? So he's currently behind the grid. So I'm gonna turn off the grid for a second, and I'm gonna bring him down. So I'm gonna click on W just so that I can grab him and pull him down. So you can see this is him over here, okay? And at the same time, I'm gonna go into our main menu canvas, and I'm gonna click on UI, and I'm gonna click on image, okay? So the image is over here. It's a start image, and I'm also gonna give it the little guy. And now you can see that he's on the side of the screen. So I'm gonna show you what you can see once you're inside the game. This is what you see. Okay, you see this sprite character and you see this image character. So the difference between them is that this one is only seen by the camera, whereas this one is seen by the canvas. Okay. Also, so does this make sense? You can say no. Okay. Type. Perfect. Also, one thing you should know about the canvases is if you have an image above something or below something, it actually matters in whether something is behind or in front of something else. So if I put the image between the start and the exit button, you can see that the image is in front of the start because it's under the start, but behind the exit because it's above the exit. So this also plays a role in where it stands. Okay? So this is also something to keep in mind. Okay, great. Type, perfect. Okay. After this, let's just discuss quickly what is happening in this piece of code. So first of all, we are using something called scene manager and we are loading the scene. So what exactly is this and what is application.quit? I think application.quit is relatively straightforward. So it's basically quit the application. This is a line of code that comes within Unity. So all you have to do to exit your game is to write application.quit. And then in the start game, what you're going to be doing is you're going to be loading your scene. So how do you know which scene to load? There are a few ways to do it. And as you can see from the word that says +5 overloads, this means there are 5 different ways to load your scene. So one of the ways is by giving it something called the scene build index. So what is this one? Where does this one come from? If we go into our build settings by going into file build settings, you can see that our 0th object is the main menu and our first object is the sample scene. So this means that when we click on load scene 1, it's going to load the scene that is numbered 1 in our build settings. And this scene happens to be the sample scene. Okay. Once we do this, we're going to be able to load our scene. Another way of doing this, if you don't want to use the build number because you might add more scenes here and there, and this might cause problems, is by writing out the name of the scene itself. Okay. So you write sample scene. So this is another way of doing it. But most importantly, when you want to load your scene and use the scene manager, you must make sure to write this line, which is using Unity Engine .scene management. If you don't, you're not going to be able to load your scene manager and you're going to be confused. I know I was at one point. So we wrote these two functions, but where exactly are we asking for them to do the thing? Well, we're doing it in the buttons, of course. Now, when we create a button, you're going to go right click, UI, and then where is it? Button with a text mesh pro. Text mesh pro is just the text that's written on the button. So you can see over here that it's got the text TMP. And if I do whatever, you're going to see the whatever on the text. Okay. Inside the start button, we are going to have something called an on click. And inside the on click, we are going to drag the function. We're going to drag the game object with the script attached, and we are going to choose the thing. So I'll just do it in front of you once. So let's say our button has nothing inside of it. We're going to click on plus. It's still empty. But we know that on our main menu canvas, I'm just clicking on these, by the way, to hide them. You can see that on our main menu canvas, we have our main menu script. Okay, so we're going to go into our start button, and then we're going to click on the main menu canvas, and we're going to drag it into this thing over here, which says none, and we want to fill it out. Okay, and then instead of no function, we're going to go down and we're going to see the main menu. And over here, we are going to click on start game. And the reason we chose start game is because this is the start button. Pretty self-explanatory, and I think this should be good to go. So once we do this, we're able to start our game. Let's test it out. So I'm going to go into full screen mode. I'm going to click on play. Hopefully the reload doesn't take too long. Basically, because we did a few edits to the scene, it decided to panic. And I'm going to click on start. So once I clicked on start, it took me to the next scene, and I can now play the second scene. Okay? Do we have any questions about this? Does it make sense? Awesome. Perfect. One word of caution is one mistake that I used to do is sometimes my button didn't work even though I had the script on it. And the reason was because I actually dragged the script itself from the scripts into the onClick. So just make sure not to do that. You must drag a game object with the function on it in order to click. Okay? Again, this is something I lost hours on, so just make sure that you don't do the same mistake. Okay. All right. We are going to take a 5-minute break in 4 minutes. But I just wanted to explain one final thing with the UI, because we didn't talk about the hearts. And then Fouad's going to take over and he's going to explain event systems. All right. So inside the grid, inside the canvas, sorry, as you can see over here, we've got a canvas. And inside it, we have the hearts bar. Okay. So the hearts bar is this bar of hearts. And we named it this way because this makes sense and we are smart. Okay. So as you can see, we gave this object something called a horizontal layout group. So can anyone guess what a horizontal layout group does? It's pretty self-explanatory, isn't it? Yes, absolutely. And it puts them in a horizontal line. So we can basically play around with the padding and the spacing to decide how we want the hearts to be. So over here, for example, we have the child alignment as upper left. If I change it to upper right, for example, depending on how big the hearts bar is actually. So, okay, this is the hearts bar at the moment. All right, you can see that this is its size. It is basically just this. So if I grab onto this and increase its size, okay, and then choose to go for upper right, for example, you can see it automatically switched to the right side. Okay, so depending on the child alignment, you can basically just play around with all of this. And you can also add as many items as you want, and it will automatically align them in a very neat way in a horizontal layout group. Can anyone remind me why these things are blue? No, it's not because they're children. It's because they are prefabs. Well done, Austin. Exactly. So yes, 100%. No, it's okay. Don't worry about it. So prefabs, as we said before, are things that we have created before. And instead of changing every single one time, we can change one thing and everything will work well. Okay. So what I'm going to do is I'm going to show you like a small thing. I'm going to double click on PF heart parent, and you can see that this is the heart. Okay. We've got an empty heart, which has an empty image. And we have a heart, which has a full image. And we have the heart itself, which just encapsulates the heart. Okay. So if I decide to, I don't know, let's say I didn't like this image and I decided to unclick this. Okay. So as you can see, as soon as I unclicked the heart, all of the hearts, the red hearts disappeared in all of the prefabs. And this is because they are all coming from the same one prefab. Okay. And these are the hearts. In these 5 hearts are the hearts that we have connected to our player inputs. And these are the hearts basically that, where are they? These are basically the hearts that we are playing around with and decreasing in number using the player HUD. Okay. Okay, I'm almost out of time. But in general, what the player HUD does is it allows us to set our health, take damage, and heal. And depending on each of these, it's going to create, add, or remove a heart. Okay. Um, does anyone want me to go through this? Well, is this clear? Should we take a break? Perfect, okay. Let's take a break and be back in a bit. And we will talk in a few seconds. Cool. Well, I mean, recording is going to be in a few seconds, but you get what I mean. All right, and we are back. And now we are switching, I'm tag teaming with Fouad, the pro programmer on the team. Fouad is also one of the organizers of the Gaming Academy, by the way. He's was also one of the winners in the first round of the GA. They made a game called What Remains of Ish, him and Sasha. And you know, it's honestly a pleasure to have him give these sessions and, you know, have me give the sessions alongside with him. So he's going to be talking about events. He has a few more slides and is definitely more organized than I am. So yeah, Fouad is also going to show us a bit about what a build looks like in Unity, and then what working, you know, working with events is like. And I will stop talking and give the stage to him.
Thank you so much for the introduction. So hi everyone. Like Ashraf said, my name is Fouad Abou Harfoush. I've been a Unity developer for around 6 years, and you know, all the stuff that he said. But let's just get into it. So first of all, Ashraf showed you before what a build looks like on Mac. So just so for all the Windows users out there, I'm going to show you what it looks like on Windows. So here I've already made the build. So I'm just going to go to the folder that's generated. As you can see here, we have a bit more stuff than the Mac build. We have a DLL, we have an executable, we have actually a couple of executables, and some folders. So in general, if you want to share your build with anybody, this folder here that says _ do not ship, you would delete it, like I'll do so, and go back here, and let's add it to an archive. Okay, and it will just it's just going to zip the folder, and that way you can very easily share builds between either your teammates, or to show it off, or to even upload it on certain platforms for other people to play. Yeah, that's basically the only difference, is a bit of a file structure from Mac. Okay, so let me go to my slides. Okay, so far, what we've covered here in this session is you've seen how to create a character that can take damage. You've seen that they have a float value of health, and we're decreasing that, and you've also seen how to create a UI to represent that health. But what we've not seen so far is how do we connect these two things? So how do we know when a player hits a spike and takes damage? How do we tell the UI to go ahead and remove a health bar, a heart from the health bar? So there's a couple of different ways you can go about doing this. You can say in general, how do two distinct systems communicate with each other? So let's go. One way of doing this is using what is called, what is known as a singleton. So singletons are a design pattern. Design patterns in programming, think of them as blueprints. They're blueprints that have been built to solve common problems that we encounter when developing applications. A singleton is one such design pattern. What it does is it basically makes sure that only one instance of a class exists while allowing other classes, scripts, and components to reference this this singleton very, very easily. How does that work? So if you look here on the left, we have an example of a singleton. You can see we have public class singleton model behavior. You've already seen this a billion times at this point. And we have this line here, public static singleton instance. So this static here, you've probably not seen it. If you've written, programmed in other languages, you've seen it a lot. Basically, this static, it's a modifier to the singleton instance here. And what it does is it says this instance property is a part of the class itself, of the type singleton itself, and not something that you need to define when you create an instance. It also makes it so that this instance here is globally accessible. So I'm going to show you an example. Don't worry if you are confused. Let's go here. And here I've created a little class called singleton. So as you see, it's the same as what you saw on the slide. I'm going to create a little public function here with void do a thing. Okay. And first of all, I want to show you what I mean by an instance of a class. So normally, when you have a class, if you want to access its properties and its methods, you're going to do something like this. Singleton, let's call it my new singleton, equals new singleton, open and close parentheses with a. So this is basically creating a new instance of our singleton class. And here we can do, let's create another function, for example. Let's do a thing too. I can call, do a thing too, like so. This is what I mean when I say an instance of a class. But because we have defined here that we have this public static singleton instance, what we can do instead is, and let's go to another, actually I'll keep this method here for the example. If we go to the player controller, for example, and here in our take damage, let's say I want to do a thing in my take damage function. So we can just say singleton dot instance dot do a thing. Very simple. We don't even need to say, we don't need to create a new instance. We have this here, which we can access from wherever we want. So this is one way of creating one way that you can communicate between two different classes is by using a singleton design pattern. This code here that's in the awake function, which will just run as soon as we hit play in Unity. It's very simple. It just checks if the instance here is null, then it will set it to this. This is just it's just a shorthand that means this class here. If it's not null, it will destroy itself. So this just makes sure that we only have one instance of the singleton, because we don't want to have multiple instances of it. We just want one. So the reason I'm talking about singletons is if you ever go watch a tutorial on how to do a thing in Unity, or you will see it used a lot. And it's a very simple way to make things globally accessible and easily accessible. It's a very easy way to communicate between different components. But it has mainly, it creates dependencies between your different components, your different scripts. What do I mean by dependencies? So when you have one component that relies on another one to work correctly, we say those two components are dependent on each other. So let's say we created a singleton to manage our user interface, and we're using that in our player script. We can say that the singleton, the player script, is reliant on the singleton. So they're dependent on each other. If for some reason we get rid of it, we get rid of the user interface, then the player script will stop working, which is, it's bad because it doesn't really make logical sense. Is it like referencing using an object in object-oriented programming? It's a way to reference an object. It's a way to reference it. It's basically like it's a static reference. Why use a class with a static number of itself and not make the class static from the beginning? Basically, because if you want this class to exist on a game object as a mono behavior, I don't think you can actually make it a static class. So for that reason, we tend to use singletons in Unity, because we want them to be mono behaviors, and that will not work if the class is static. I will get to the two. If you have more questions, I will get to them in a bit as I keep. So yeah, dependencies. Dependencies are not very good because they make it hard to scale and to test your game/application. So what do I mean by scalability here? Scalability means if you want to add more features, if you want to add more methods or properties to an existing class, or just add anything, that's what we refer to as scalability. How well does a component do as we add more features into our codes and our game? And testability is, I think, very you can understand it very easily. It just refers to how easily it is to test our game. And when you have big projects, mid-level to like large level projects, you want to avoid having dependencies because it can very, very quickly get out of hand. Yeah. Do I have any questions so far? Let's see. The community needs to be instantiated as a game object to use mono behavior. Yes, sort of. That's kind of how it works. You need the class to be a mono behavior for Unity to understand that this can be attached to a game object. And also the mono behavior just gives it, all the start and the update and all the functions that come with Unity for it to function within the Unity system. That comes from mono behavior. Okay. So we talked about singletons. We talked about how to use them and their ease of use, but why we should maybe avoid using them, especially in bigger projects. So what do we do? How do we communicate between systems without using singletons? So this is where events come into play. An event is a trigger, and when an event is triggered, it notifies other components, other objects to do something. Basically, if we look here at this diagram, we have a player death event. So when the player dies, we say we raise this player death event, or we broadcast it to some other components that are listening to this event. And once they hear that this event has been called, they will do certain things. So here, for example, when our player dies, we want to respawn the player. We want to fade out the screen. We want to turn off the inputs. We could also like play a sound effect, play a visual effect, and on, we have a point in our logic where we want other things to happen simultaneously. So this is why events do basically. You can think of them as sort of notifications. Okay. So how do we make events in Unity? Or how do we make events in C#? This is where delegates come in. Delegates are basically a reference to a method. So you can think of them, if you want, as a special type of variable that reference methods as their value. So you know how you have floats, and a float has a value of 5, for example, or 5.5. A delegate can also have a value, but that value, that things which it points to, which it references, is a method within itself. So here, if you look at the example, you see we're defining a delegate, and we're saying that my delegate attack, we're defining it. And you see here we have two methods, primary attack and a secondary attack. In our start, we're assigning primary attack to our attack delegate. So what do you think here? What do you think is going to happen when we call attack? Wait a little bit to see if anybody answers. Something will attack. Same thing as calling primary attack. Yes, exactly. Same thing as calling primary attack. So here in our case, we're just outputting a debug log called primary attack call. So this is so if we do this in our code, we'll see in the console, it's going to print out primary attack call. So yeah, this is what basically a delegate is. They're useful for us because it's very easy to change what a trigger does without changing the trigger itself. So here we can say attack equals secondary attack, or if we create another attack, we can say attack equals third attack, so on, you know. And we're still only calling the attack delegate, but what the attack delegate does is changing because we're changing what method it's pointing to. Yeah, we could call that's basically what I just explained. Is we can change the nature of the delegate's function, what it does. Are we clear so far? Do I have any questions? Okay. So now we're not going to use delegates in our example. We're actually going to use something called actions. Now, actions are just a simpler way to define delegates. If you see here in our example, when we wanted to create a delegate, we had to write delegate void my delegate and then my delegate attack here. So we're not going to do this. This way of defining actions give us just a simpler way to define a delegate. You can see here, we say public action on take damage. That's basically the same as if we said, sorry, if we did this delegate void my delegate. So actions are just a simpler way to define delegates. I'm actually going to go to the code now to show you this in action. So here we have a class. It's called the player events channel. And you're going to notice here that it inherits from something other than mono behavior. And I'm going to cover this in a bit. So don't worry about that right now. But in our player event channel, we have a public Unity action on take damage. So this is what we're going to use as an event. I'm actually going to refer to this as an event. So this onTake action event, we can call it in a couple of different ways, right? We can say onTake damage like so, or we can say onTake damage dot invoke. This dot invoke is just going to basically call our onTake damage event, and anything that's listening to this event is going to do something. We'll get to that. But this is how we invoke an event. So let's see here. We have our onTake damage. In our raise onTake damage methods, we're just saying onTake damage invoke. So we're just invoking this event. I'm going to right click and click find all reference here. So you can see down here all the places where this onTake damage unity action is being referenced. So as you can see, it's being referenced here in our player HUD scripts. If I double click, it takes us to the script, which, just for reference, in our Unity project is right here on our canvas. Let me just minimize these. It's right here. So this onTake action event, when it's invoked, the player HUD script is listening to it. So this line of code here is basically saying the onTake damage event of the player channel plus equals handle take damage. So what does plus equals do? So we call this subscribing, and here minus equals, we call this unsubscribing. So here we're subscribing the onTake damage event to this method, or sorry, we're subscribing the handle take damage method to our event. So when this event is called, this method is going to be called, kind of like how our delegates were assigned a method. It's basically what's happening here. We're assigning this method to the onTake damage event. So here, when this method is called, it's going to invoke the onTake damage event, which will call this function. And if you look here in this code, it's just checking if the heart's parent's child count is bigger than 0. If it is, then we're removing a heart. So this is the code that's responsible for removing a heart when you take damage. So where is this event actually called? Let's see here. I click on find all reference and I go to our player controller script. We can see here on our take damage function, right here, we're calling player event channel dot raise onTake damage. So here we're calling this event, and this will call here to invoke, which will in turn tell the player HUD script to handle take damage, which will run this piece of code. Any questions so far? Can that multiple methods like events? Yes. Yes, it can reference multiple methods. So here in our example, let me just go back here. Here, if I, instead of writing attack equals primary attack, if I wrote attack plus equal primary attack, and then on the next line I said, excuse me, I said plus equals secondary attack, then you're basically telling it you have these two methods that you're referencing. So when you call it, it's going to call both methods. Awesome. Okay. Since we have no questions, I'm going to assume that it's clear, but please, I know that this can be a bit of a difficult thing to wrap your head around, so don't worry if you have some questions. I'm very happy to go over it again. Okay. So here, now that we have this onTake damage event, I can go to another script and say, let's say we have a sound effect script, and I can do the same thing I did here and subscribe the take damage event to a method, and let's say I want to play a sound effect. So this is a way. I hope you can start to see that you can communicate between different systems and different components in your game without really creating dependencies between them. Right here, the player controller, all it does is it raises this event and then it just doesn't care. You know, it goes upon its life, it checks whether the health is less than 0. It doesn't care if the event actually did anything. It just raised it and it went along. There is no hard coupling between it and another method. Like one thing we could have done here is player HUD, for example, and then here we could have just called, well, this is not a public function. So if I just make this public right now and go back here, I can say dot handle take damage, right? And if I remove this, this is basically the same thing, right? It's taking damage and then it's telling the player HUD to remove a heart. It's exactly the same thing, except here we have a very rigid hard reference to our player HUD. If this for some reason stops existing in our code, then the player will stop working, which is not very good. Okay, so now let's go back to this player event channel and let's talk about this mysterious scriptable objects. What is a scriptable object? So far we've been creating mono behaviors, right? Mono behavior here, mono behavior there. A mono behavior basically, to put it simply, what it lets you do is this, right? It lets you take a script like the player HUD, for example, or let's say the player shooting controller, and just drag it and drop it here. And now this script, this canvas has an instance of the script attached to it, and it will run when we press play and everything. So this is what a mono behavior does. What does a scriptable object do? How is it different? Basically, let me go back to my slides. A scriptable object is a data container, and it stores data independent of class instances. When you create a scriptable object, you're kind of creating an object that can live in your file system, just like a sprite, like a .png file that you have in your file system here. It will live inside of your folder. So let's see it in action. Actually, I'm going to create a new script. Let's call it player data SO, and here SO just stands for scriptable object. We're going to open it, and we're just going to say this is a scriptable object. And here, I want to use the scriptable object to just store my player's data. So I'm going to have a public, public float, player health, let's say, equals to 40. And let's say, no, not partial, public float, player speed equals to 5. And of course, you can have any types you want. You can have vector 2s, you can have booleans, you can have anything here. So now that we've created the scriptable object, if we go here, we go back to our Unity project, and let's try to drag it and drop it here. And you see we get an error. You can't add script behavior player data SO. The script needs to derive from mono behavior, which it does not. So what do we do? How do we access this data? Here, what we can do is we're going to create, we're going to write, open these brackets and write create asset menu. So this is an attribute, what we call an attribute. And this attribute here, we put it above our class to say that, hey, this class can be created from our asset menu. What's our asset menu? Well, it's right here. If we right click anywhere in our project here, and we go to create, we see at the top here, we have player data SO, which is our scriptable object. So let's do create player data SO, and you see it's created this new asset in our project called new player data SO. As you can see, it has the player health and the player speed. So this is basically what a scriptable object is. It's a data container that lives within the project itself, instead of something that you put on a game object and then it's the game object is referencing that script. It is living inside the project. Okay, so why do we care? Why did you just explain this to us for 10 minutes? Why do we care about scriptable objects? Well, they have a couple of use cases that are pretty important. So if you have data that is frequently used in your game, it's usually a good idea to make it a scriptable object, because every time that data is referenced inside your mono behaviors, inside your script, you're actually allocating memory for that data. What a scriptable object lets you do is you have one place where that data lives in your memory, and your objects will just reference that one place in memory. So it's a bit of an optimization. And it also lets you, organize your data in a better way. Another use case is defining global variables. So think of your game settings, for example. Actually, this is similar to the first use case. You have global variables might be used in many places in your project. So it's a good idea to use them, to put them in a scriptable object so that it's easier to reference them and you're not creating more instances in memory. And another very useful way, which is important to us here, is they work well as a basis for event systems. So let's see what I mean by that. Let's go to this player event channel. It's a scriptable object, like the one we just created here, which means if we go to our project and we right-click and go to create, you see we have this player event channel, and we can create it. And here it's created a new dot asset. Let me just move this 1 second. It's created this dot asset object, which is our scriptable object. You see it has this little icon, and if you see this icon anywhere in your project, that means that that thing is a scriptable object. So this player event channel, you can look here, it doesn't actually have any properties. We can't go in here and change because all it has, as you can see here, is actions or events that we went over just a little bit ago, including our on-take damage events. So the reason we did this is because we need an easy way for our player to call this on-take damage event and for our UI to listen to this on-take damage event. And we do this through the scriptable object. If we look at our player here, you can see it has a max health, it has a reference to our sprite renderer here, and it also has a reference to our player event scriptable object here. And if you look at our canvas in our player HUD, you see it also has a reference to the same scriptable object. And if we look at our code, what is this doing in our code? So we see we're using it in a couple of places, but let's just focus on the raise on take damage. So now we know what this is. We know what the player event channel is that we were looking at before. It's the scriptable object and we're calling raise on take damage on it. So here it will call it, and in our player HUD, which is referencing the same scriptable object, when on awake, when we start our game, when we run it, it looks at the scriptable object, says this on take damage event. When it's invoked, I want you to call handle take damage. So this on take damage is the same one that's here, which is the same one that's referenced here, because both of these objects are referencing the same scriptable object. So that is how they're communicating. That is why I refer to them as channels. They're like tunnels between one script and another. That's basically it. That's basically all I had to cover. So please let me know if it's been clear so far. If you have any questions, if you want me to go over anything else, the floor is yours. Anybody else besides Ashraf? I'm super happy to hear that. This is actually a topic that I've been wanting to cover for a while because it's very easy when you're starting out to fall into the trap of using a lot of singletons. And I fell into it myself on a project that was pretty big, which became a hassle. It's okay. I want to actually emphasize something. If you're prototyping, if you're trying to get things done very, very quickly, using singletons is incredibly valid. You can use them. They're very easy to use. They're very fast to use. The point I'm trying to get across is once you start feeling, okay, this is a project that I'm going to be working on for a while, it's going to get bigger, you are going to start to want to think about how you create the architecture of your code, of your project. And thinking of how, and event systems is a way to create communications between your objects that doesn't involve creating a mess of dependencies that will haunt you for the rest of your life or the rest of your project. Okay, well, so far it doesn't look like we have any questions. Just to make sure. Public action, you invoke it when the player gets damaged. Exactly, yes. The action is on the scriptable object. We invoke it when the player gets damaged, and the HUD also references that scriptable object, subscribes that event to a method that updates the HUD, 100%. Do you still want me to repeat the question? Okay, so the question that was asked is just to make sure, is Muhammad was trying to know if this is how what I just described is working. You have a public action on a scriptable object, you invoke it when the player gets damaged, and then the HUD has a reference to that action and it subscribes to a method that updates the HUD, which is exactly right. They also asked that if they're all linked through the scriptable object from the inspector. Yes, all of these are linked through the scriptable object. That's why I got into the topic of scriptable objects. You can definitely, do them in a way that doesn't use scriptable objects. This is actually very similar to an observer pattern, which is another type of design pattern that you can, after this course, you can go and look if you're interested in it. But I find this way to be very easy. Awesome. Okay, well, that's it for me. Unless we have any other questions, I think we're good. You're welcome. I'm happy to hear that this has been a good learning experience.
Cool. Thank you so much, Fouad. This was absolutely fantastic. I'm actually going to rewatch your session after the recording is up because this was very useful for me, and I really need to use this in my own projects as well. And I need to get used to the channels and the scriptable objects and all that.
Yeah, it can definitely be hard to get used to it, but it saves you a lot of time later on.
Yeah, absolutely. So yeah, thank you so much. Thank you everyone for attending, and we'll see you in the Discord server. And in the next sessions, we have like a few more dev sessions. We have like 2 more, I think. So this will be fun. Yallah. Take care, y'all.
Bye-bye.